In this video, we are going to look at how to graph an equation of a line that is in slope-intercept form. So we want to make sure that when we see y equals mx plus b, we recognize that we are in slope-intercept form. Now, you might remember from a previous lesson that slope can also be referred to as the rise over the run, which is also the same as the change in y over the change in x. Now, let's break that down even a little bit more and make it more relatable to our coordinate plane. When we talk about the change in y, we're talking about any vertical movements. That means we're moving up or down on the y-axis. When we talk about the change in x, we're talking about any horizontal movements. So that means we'd be moving right or left on the x-axis. Now, you might wonder, well, how do I know if I'm moving up or down? Well, you look at the number in the numerator spot of the slope. If it's a positive number, that means you're moving up. If it's a negative number, that means you're moving down. Then you look at the denominator of the slope. If it's a positive number, you move right. If it's a negative number, you're going to move to the left. So the sign of the numerator tells you to move up or down, and the sign of the denominator tells you to move right or left. All right, so let's get an equation here and graph it. So we want something in y equals mx plus b form. So let's just start with something like this, y equals 2/3 x minus 2. So I can see that I have an m and I have a b. So let's look at the m first. So the m value represents the slope. You can also think that the m stands for move. So the number in the m spot tells you how you're going to move up, down, or right, left on your coordinate plane. So that is also the slope. So in this case, our slope is 2/3. So our m equals 2/3. So in my numerator, I have a positive 2, which tells me to go up. And in my denominator, I have a positive 3, which tells me to go right. So now I know that I'm making movements of up 2 units and right 3 units. But that doesn't really help me until I know where to start. Like, where do I start my movements? Where do I start moving from? So that's where the B comes into play. You could think of B for begin. So B is where you begin, and then the M tells you how to move from that beginning point. So the B represents the y-intercept. So in this case, our B is -2. But that tells me that I am sitting on -2 on the y-axis because it's the y-intercept. That has an ordered pair. If I'm sitting on the y-axis, I am at the point 0, -2. So that's my beginning point. So I'm going to start by plotting my ordered pair at 0, -2 right on the y-intercept. So there, or right on the y-axis. So that is my y-intercept. Then from there, I'm going to start moving up 2 units and then right 3 units. And every time I do an up 2 and a right 3, I'm going to put another dot. That's another solution to the equation, which means it's another point on my line. I'm going to do it again to get a more accurate line. You can do it as many times as you want. I recommend 5. I always say 5 ordered pairs is a good collection of points to draw a straight line. So I'm going to go up 2 units, right 3 units, and then I'm going to put another dot for another ordered pair. Now, I could keep going up 2 units and right 3 units, but then I'm leaving out the left side of the graph. Notice how I'm going up 2 units and right 3 units. I'm only making my way into quadrant 1. But we have to remember the line extends infinitely in both directions. So this line is also going to extend into quadrant 3. Well, I want to see some of those points as well. So let's think of the slope in a different way. I know my slope is positive 2/3, but that technically is the same as -2 over -3. Because remember, a negative divided by a negative is also a positive. So -2 over -3 would simplify to positive 2/3. But if I think of it as -2 over -3, I could also think that I can go down 2 units and left 3 units. Remember, go back to that beginning point. So I'm going to go back to that beginning point, and now I'm going to go down 2 units, left 3 units, down, and put a dot for my next ordered pair. I'm going to go down 2 more units and left 3 more units and put another dot for another ordered pair. So now I have 5 nice ordered pairs, so I can draw a nice accurate line through my graph. But remember what I said before, the line extends indefinitely in both directions. So we're not totally finished graphing until we put those arrows on the end of each, or until we put those arrows on each side of the line. Now we have a collection of ordered pairs that extends indefinitely in both directions, which is a visual representation of the equation y equals 2/3 x minus 2. Let's take a look at another example. So remember, we are still graphing lines in slope-intercept form, which means our equations are going to be of the form y equals mx plus b. So in this example, we're going to look at y equals negative 3x plus 1. So remember, the m represents the slope, and the m also tells us how we move. So in this case, our slope is negative 3. Now, in the last example, you'll remember how I said look at your numerator of your slope and look at your denominator, because we want change in y over change in x. Well, now our slope is an integer, so you're probably saying, well, where's my denominator? No worries. This is an easy fix. Instead of negative 3, we're going to write it as negative 3 over 1. Bam! There is our rise over our run. So anytime your slope is an integer, just write it over 1. Problem solved. So now my numerator is negative 3. That tells me to move down. And my denominator is positive 1, so that tells me to move to the right. So I have a down movement and a right movement. But remember, I need to know where to begin from. That's where the b comes in. The b is the y-intercept. So in this case, my b is positive 1, which tells me my y-intercept is at 0, 1. So we're going to start by putting an ordered pair on the graph at 0, 1 on the y-axis. Now we can start to move. So I'm supposed to go down 3 units and right 1 unit and plot another ordered pair. Let's do it again. Down 3 more units and right 1 more unit and plot another ordered pair. But as you can see, if I continue going down 3 and right 1 unit, I'm only filling in the ordered pairs that are in quadrant 4. Remember, the line extends indefinitely in both directions. If I were to extend it in both directions, I should also see some ordered pairs in quadrant 2. So let's look at the slope in another way. We have a slope of negative 3. That can also be interpreted as positive 3 divided by negative 1. So positive 3 over negative 1 would also simplify to a slope of negative 3. Now I can move up 3 units and left 1 unit. So let's go back to my beginning point and let's start traveling up 3 units and left 1 unit and put another ordered pair. Up 3 more units, left 1 unit, and put another ordered pair. And you can see the 2 new ordered pairs I just plotted in quadrant 2 fall in the same pattern of the other ordered pairs. So it's all one nice straight line. So I can draw the line between all the points, but remember, my line isn't complete unless I have my arrows. Now, notice how this line is sloping downwards. That's because my slope, was a negative value. So I always tell students, when you're done graphing your line, make sure the direction of your line matches the sign of your slope. So if this line is going in a negative direction or has a negative correlation or is pointing down, as I look at the graph from left to right, the line is going down. That matches the negative sign of my slope. So those two things should match. Hope this was helpful.